System design has become synonymous with a portion of the tech interview process that has been popularized by some big tech companies. But trust me when I say this, the world of software engineering and system design in particular is so much broader and wider than just web backends and the sphere of big tech and mobile apps and so on and so forth. I want this video to be your ultimate guide of how to design systems that will actually be used in the real world, beyond the theoretical scenarios that you could potentially get quizzed on in an interview or whatnot. This video is going to be quite dense. It's going to be a masterclass of sorts, and it's going to be a condensation of all of my years of experience building, designing, and maintaining systems beyond web and mobile backends. I'm going to walk you through my thought process and my approach end to end. We have a lot to talk about, so let's get started. I started writing code when I was about 12 years old, and I really had no clue what I was doing at the time, but there was something about computers that really captured my imagination ever since. And throughout my career, I've worked as a software engineer in digital agencies, startups, enterprises, as well as big tech. I have led and managed small R&D units. I've also worked as a management consultant where I have led the high-level design of an advanced traffic management system that is currently used in one of the most complex surface and tunnel transportation operations in the United States. I managed the furnishing of a container terminal, where ships come in to load and unload cargo, with all of its systems from the fiber optics layer all the way to the 3-tier data center and all of the enterprise systems that run on it. I helped found a software engineering bootcamp where I taught software engineering for about 3 years to hundreds of students. And now I work at GitHub helping make GitHub Actions a little bit better for all of you. All of this to say is that I'm not necessarily an authority on the topic, but I've seen stuff. And I'm very thankful for all of these opportunities that allowed me to see software engineering and systems design in general from different perspectives. And there's plenty more to explore in this field, and I'm really excited about that. All of this helped me enrich my mental models and avoid getting stuck in a box designed by others. And right now, I want to share these mental models with you. So the last thing I want you to do right now is to shut down your brain and go on an autopilot mode. And what I mean by this is a lot of the time people consume content very passively, and they use it as a recipe or as a prescription for how to do things. This video isn't a recipe. I want you to think of this video as a reference that you can draw inspiration from, that you can learn from, and then use this learning as a foundation to build your own process. You will also notice that I use architecture and design interchangeably. This is because personally, I don't believe there's a distinction between architects and software engineers. I see architecture or system design as a function that pretty much anyone can fulfill, and not necessarily as an office or position that someone gets promoted into. And honestly, some of the best teams I've worked at, they had engineers who could wear multiple hats. They could zoom out and describe systems at the 10,000-foot view, and they could also zoom in and discuss all of the intricate details of the implementation. This is definitely the sweet spot you want to be in. And someone will come in and say, oh yeah, but not everybody's like that. And sure, but everybody can aspire to be like that, right? Now keep all of these things in mind as you move forward. There are 3 fundamental questions that you should always ask when designing systems and exploring new topics in general. What, why, and when? Now let's start with the what. And honestly, this is the most obvious of the 3 questions because the intention here is to do discovery work and avoid having another party describe in detail what needs to be built. Because having someone else describe in detail what needs to be built is a trap that junior software engineers and inexperienced developers fall into. Because they expect that the what is already defined by some product owner or maybe some other stakeholders. Experienced engineers and architects understand that while these stakeholders might have a more or less concrete idea of what needs to be built, the end result might not necessarily look like what these folks had imagined, especially after we factor in all of the different technical constraints. That's why you as the system designer, you need to take agency. And you need to be involved in defining the what, not just be a recipient of the what and you figuring out how you need to approach the building process. My approach to this phase is to be playful. This is not necessarily a competition of who's smarter or a competition of wits. You need to optimize for extracting information as much as possible from these stakeholders. You need to be the one who asks questions that would put everybody in the thinking mode. You need to be thought-provoking without being too patronizing, authoritative, stubborn, or just plain annoying. Because some people confuse these behaviors with looking smart. This is not about appearances, and no emotions should be involved in this phase at all. You're observing, you're tinkering, you're poking, you're playing around with the ideas, you're discovering. No one has the answers at this point, even if they think they do. And there are a lot of different frameworks available right now to facilitate this whole process, design thinking or some other brainstorming frameworks or some of these, boards where people have sticky notes and, they can just write down their ideas and just put them in different columns and whatnot. And that's all fine. I have personally reached a level of experience that I'm able to drive the entire conversation in a meaningful direction without necessarily the need to rely on any such framework. I personally think it's just much more efficient, and if we can figure out a very, nimble way of doing this without the bulk of some of these frameworks, especially when they're not really necessary. Because what I've seen in the field is that some people take these frameworks, they swear by them, and then they just apply them to everything. Lastly, while this is play of ideas, all of this needs to be documented in some way. These conversations could happen in a meeting, they could happen over a coffee break, they could happen over a specific dedicated brainstorming session, they could happen over a random conversation somewhere. So don't necessarily be rigid about the format, but make sure that whatever approach you adopt, you record the information. Otherwise, it's a waste of time. I personally love to use mind maps for all of these things, and I'm gonna talk about mind maps in a little bit. Now, the second most fundamental question is the why. And the purpose of asking why is to deepen the exploration that was started with the what. It's a way to dive deeper into the intentions. It's a way to unpack the unspoken. It's a way to understand what people think but don't necessarily say. And it's a way to identify the raison d'être, the purpose of why something should exist or should be built or designed or whatever. Now, if you ask why 5 times to any person, you will either reach a very substantial level of depth or you will be stuck at any of the previous levels. So for example, if you ask someone why the first time, they can answer it. If you ask them the second time why, they can answer it. If they answer the third, fourth, and fifth time, that means they have really thought about this topic extremely deeply and they have really developed this model in their mind of this area very thoughtfully. However, if you ask a person why and they cannot answer the second one or even the third one, that means they have a very shallow surface understanding of this topic and they might have just had an idea, but they didn't really explore it very well. So in short, reaching higher levels of depth by asking why is an indication of the maturity of ideas. That doesn't necessarily mean that every idea needs to be beaten to death and you need to reach the maximum levels of depth by asking the why for each and every single one of them. You need to use your best judgment here and evaluate what is the appropriate level of depth given all of the circumstances, the stakeholder you're dealing with, and the situation overall. Now, as I said, understanding the why is critical. Otherwise, we will just be robotically executing on instructions. And while some engineers might want to do exactly that, be given specific details of what to build and then they go and play with the code, it's our job as the more senior engineers and architects to do the work that nobody else wants to do. We need to be the ones who explore the uncharted territory, unpack the difficult questions and try to reason about them and help everybody align on why and what, so that when the time comes for the implementation, we're all speaking the same language. And having the ability to execute on this phase is really a true sign of maturity, experience, and leadership. Now, be careful with asking why prematurely. If you ask why too early, you might look too confrontational. You might look extremely provocative. What you want to do is first you want to play with the what. You want to give space and room for others to tell you what they have in their minds. And then you can ask the why to enrich and decorate that understanding you've explored and adding a purpose to it. Because understanding the purpose without understanding the what is completely meaningless. There's honestly nothing like coffee to get the brain juices flowing, and this is a pretty cool mug that was given to me by my former colleagues. It has this cool contributions graph of GitHub printed on it, and it's pretty nice. I use it daily. All right, let's move on with the third fundamental question, and it's the when. This is the question that is loved by everybody because it involves estimations and talking about timelines and deliveries and all of that fun stuff. Now, when I ask the when question, there's generally two types of answers that I could be given. Number one is that there's definitely a date that has been defined and there's a timeline. The second one is that there isn't one. And 90% of the cases, people generally push for a specific timeline and specific delivery date, and they think this is a good management practice. We all have our ideas about it. I don't want to judge it right now. I probably should make another video entirely about this topic, and I will leave it to that. Now, I don't want you to start debating, estimates and delivery dates and all of that stuff at this phase. Right now, you should think about the when as a simple question, just to gauge if stakeholders have maybe a business critical scenario, or they have a very strong case for why they are picking the date that they have chosen. And you don't need to be defensive here and say, oh no, this is not feasible. Don't go into these conversations now. Now you're just listening, you're just absorbing, you're just taking in, and you can consider this as one extra data point that you factor in your design process and your design thinking, because now you're going to take all of this stuff and then you're going to think about it, right? This is where you go into the design mode. And when thinking about design, there are usually three different elements that go into this. There are resources, there are timeframes, and there is what is being delivered. And the way I like to think about these three things is visually, is I like to look at them as if they are, slide bars that are sort of connected to each other. And when you move one of the slide bars, the other two will change as well. So for example, if you increase the number of resources, you will have to reduce maybe the timeline and increase the amount of deliverables. If you increase the amount of deliverables, you have to extend the timeline as well and maybe even increase the resources. You extend the timeline, you can potentially reduce the resources, and I say potentially, and maybe even increase the amount of deliverables, right? So there is sort of a relationship between these three. And how does that relationship look like specifically? Can you really come up with a formula for this? It's very, very difficult because it's not just related to these three variables, and a lot can come into play, but it's useful to think about them and reason about them in this specific form. And honestly, this phase, when you ask the when, is when sometimes shit hits the fan, because some of the immature stakeholders, product owners and whatever, they will impose a deadline and they will say, you need to deliver by this date. Or what they will also do is they will push you to give them a estimate that they will take as a commitment. And I honestly really hate this, and because they're taking away my agency, they're taking away my role in the process. And what I hate about it as well is that it gives me an indication that the person I'm working with is not necessarily working in good faith, or they're coming from a very traditional managerial background, or they probably don't have experience. They're either too junior or they really don't know how this stuff works, and they are just trying to come in here and create a place for themselves, try to be authoritative and look like they are actually in control.
Oh, well, king in the castle, king in the castle. Have a chair, I have a chair. Oh, go do this, king in the castle.
If you ask the when question and it goes well, and you really have an honest conversation with the stakeholders about the realities of this and the realistic timelines, and they understand it, that means also that the previous two phases went well. That when you ask the what and then you ask the why, and you really unpacked it well, the stakeholders understood the complexity of what we're dealing with, or not, because not everything needs to be complex. And assuming that these stakeholders have reasonable expectations and, good intentions, they should already have understood the level of complexity you're working with. And that makes this entire conversation much, much smoother. At this stage, I personally like to provide a preliminary estimate. And I also like to add to it the disclaimer that this is purely an estimate, extremely rough, and that this figure or date or timeline or whatever it is, it's going to be extremely refined as we reduce the amount of uncertainty associated with what we're building and how we're building it. As a rule of thumb that you should always remember, the higher the level of uncertainty that you have, the further in time your estimate should be, right? And uncertainty could be around pretty much everything: resources, what you're delivering, how you're delivering it, and so many other variables that come into play. You can think of uncertainty as follows. It's about knowing what we know, knowing what we don't know, and not knowing what we don't know. And what do these actually mean? Knowing what we know means we know what to ask, and we also potentially have the answers. So maybe this is something that we've done before, we have the experience, we want to do something similar, 90% of the situation, we understand what we are dealing with. Knowing what we don't know is basically we know what to ask, but we don't necessarily have the answers to these questions. So it's something that could be similar to something we've done before, so we know what problems and challenges we might be tackling, but we don't really know how to solve them yet. And the third level is not knowing what we don't know. And this is the highest level of uncertainty. We've never done this before. We have no clue what we're dealing with. We don't even know what to ask and where to begin asking. Now you'd say, okay, so if you don't know what to ask, where do you start? And obviously everything has a starting point, so uncertainty can be reduced in many ways. You could start by doing some maybe spikes, doing proofs of concept, doing some research, maybe reading about the topic. I personally like to start with doing some preliminary research, playing around with the concept, trying different variations of understanding the what, tackling it from multiple angles, reading books dedicated for these specific topics, maybe watching some videos if there are any, but my references are always books. I personally prefer books. Videos sometimes can be misleading. Books, you can quickly skim and search through them. That's why I always go for that. Finally, I also try to make sure that the stakeholders really understand what level of uncertainty we're dealing with. And once you share this, and again, if these are reasonable stakeholders and you understand they understand these abstractions that we're talking about, this conversation will be so much smoother. Now comes the most interesting part of this process, which is determining how we're going to solve the problem, which we unpacked with the 3 fundamental questions. I'm not going to be talking about tools, so if you're expecting a conversation about databases, frameworks, programming languages, and all of that fun stuff which I enjoy talking about, head over to my software architect roadmap review where I discussed all of these things in great detail. And I outlined what every staff plus software engineer and software architect should learn and should know at different stages throughout their career. Also, if you're interested in having much more frequent in-depth conversations about this specific topic or any other topic related to software engineering, consider joining my Patreon community, specifically the Discord server, as well as my bi-weekly video call that I have with a subset of my Patreons, where you bring in the agenda, you bring in the questions, and we discuss them together. You learn a little bit from me, I learn from you, and we all learn from each other. I've been running these calls for the past 2 or 3 months, and the value is immeasurable. Now, let's get to it. This is the design phase, where a lot of different elements have to come into play. Information available, experience, your skill, maturity, leadership capacity, and so many other elements that you personally don't even have control over. And believe me when I tell you, you've probably heard this before, but I will say it again. It's never a technical problem. These are the easiest problems to solve. Like, people think that the tricky part of system design is figuring out which database to use, or whether you need to use gRPC versus REST, for example. Honestly, in my opinion, these are pretty much solved problems just because a lot of people have tested a lot of different variations before and have uncovered what works and what doesn't in different scenarios and environments. Yes, this might not be written in a structured way somewhere, but the knowledge exists. The real problems, however, are people problems. They are organizational problems. They are logistical problems at scale. Your design needs to cater for all of these different variables and for all of these different circumstances. And while in an interview you're designing on a blank slate, in reality, first of all, you're never tasked with designing a system as big as GitHub Actions by yourself. No matter your tenure or the level of experience you have, you're always working within a larger organization or larger team where you have a lot of other stakeholders and people who come in with different opinions and maybe even teams owning different parts of this. Number 2, you might have a lot of legacy systems. You're never operating in a greenfield scenario, and that's true. You might be engaging with greenfield projects from every once in a while. For example, if you work at a service company, the frequency of engaging in greenfield projects for clients and customers might be much higher than the probability of that happening within a more established organization. But also, you're going to be losing scale. So if you're starting a lot of greenfield projects, probably you're going to start with a much lesser scale, much lesser user base, so on and so forth. So again, the landscape you're going to be designing on is going to be completely different from one challenge to the other. And this is why I complain about the banality and triviality of these system design interviews, because they never ever factor in the difficult parts. They only focus on your technical skills, which is fine. I mean, it's great. It's a good test maybe, but the other problems are the harder problems. Anyway, this part of the process is also the most controversial phase. Why? Because if you ask an engineer or an architect who has only worked in SaaS product-based companies, they will say, we will design the least amount possible. We will not spend days and weeks designing systems. We are just going to build, we're going to test, we're going to collect data, then we're going to reiterate on that design and improve it for the next cycle. However, on the other hand, if you go and ask the same question to a software engineer or a architect in a more traditional industry that is much more risk averse, that cannot tolerate the same risks as a SaaS company, for example, they will say, we will start by compiling a spreadsheet of all of the possible system requirements. We're going to talk to stakeholders at the top or bottom of the chain. We're going to spend weeks collecting these requirements. We're going to hire an army of business analysts who are going to do these, this data and information collection. Then the architects are going to convene and they're going to develop a high-level design with a 200-page document describing every single detail of this design, and then add an appendix, which is basically a verification matrix or requirements verification matrix, where we connect every single design decision to the requirements that were collected before to prove that we have actually met this entire list of requirements. Then we're going to hand over this entire design document to the stakeholders for review, and maybe even have a committee review it and approve it and push it to the next stage, so on and so forth. And honestly, the truth of what is the best way to work is somewhere in between. And probably at some point I'm going to make a video just about this specific topic. But for now, what you need to remember is that not all companies can move fast and break things. Some systems are business critical. For example, I worked at a container terminal where if one of the main systems goes down, even for a few seconds or a few minutes, we're going to rack up hundreds of thousands of dollars in losses. That's number one. Number two, this downtime could potentially lead to life-threatening situation for the operators on the ground. Some systems manage our infrastructure. They manage the electrical grid, nuclear power plants, healthcare systems, emergency systems, and all of these things cannot fail, because if they do, they lead to really life-threatening situations. So it's obvious that the companies building these systems have very little appetite for risk. Now, whether this amount of reviewing and process works or not, again, that's the debatable part. It depends on who you ask, and you will get different responses for this. That is also why you don't see a new airplane model coming out every year, for example, unlike mobile phones. This process takes a lot of time, months, weeks, even years. And even when the process is done and the design is done, there's the development part. And then after the development comes the rolling out of the system, which is also a very big, gigantic issue all by itself. And all of these problems cannot really be anticipated by just one or two or three or a committee of people way beforehand. Like, for example, if you roll out a new airplane model, you know how much training you need to do for pilots all over the globe and how much costly this is going to be. If you roll out a new banking system for new employees where you have thousands of branches across the globe and people who have been trained on the old system, do you know how difficult it's going to be to just retrain all of these people? That's why I laugh a little bit sometimes at the banality of the SaaS company problems, because SaaS companies can just roll an update and the consumers will just have to live with it. Yes, we do some A/B testing. Yes, we do all of that fun stuff. And yes, we cannot really roll breaking changes all the time, but they're much, much easier to roll out than what other industries, or than the rolling out of features in other industries. And yet, a lot of the attention is focused on big tech, and it's understandable. That's where probably a lot of the money is. That's where a lot of the flashiness is. That's where the news is focused. And that's where, software that touches consumers, it's basically popular software, right? Because a banking system, only small circles know about it, how it works, and maybe interact with it. But when you build something like a social network, anybody from my mother, pretty much anyone in your family is going to be engaging with it. And that increases its popularity, that increases its exposure, and that's why the attention is focused on these companies. Now, with all of that stuff said, I start my process with my most favorite tool, mind maps. If you've seen my previous videos, you've probably seen some of the mind maps I've created for some of my previous content. I stopped sharing my mind maps, but I still create them for every single video, including this one. And I'm gonna be sharing the mind map for this video later on. It's gonna be probably a link in the description somewhere. I love mind maps. They are my go-to tool for pretty much every, deep thinking that I have to do about any topic. And the mind map is a visual diagram that represents, hierarchical information. And it also allows you to create relationships in between the different elements and the information within the diagram. Then I move on to my second favorite pair of tools, pen and paper. I have these next to me all the time whenever I need to doodle a small sketch, whenever I need to think about something, whenever I need to design something very quickly. It's always great to write down your ideas, your thoughts. And the more you do it, the better you become. The first few diagrams you're gonna make, they're gonna be very non-coherent. They're gonna be just like very random scribbles. They're not gonna look nice because you didn't really develop that skill. And diagramming is a skill all by itself. Like your ability to quickly represent information in a visual form, that needs to be developed with time. You're just not gonna come in and say, oh yeah, if I draw these boxes and create a few lines in between them, it's gonna work. It's not really how it works. You need to learn how to get to that stage. So I personally start by, creating a block diagram. And the block diagram is basically just some rectangles that represent certain boundaries. They represent the elements of the system that I'm working in. They could represent multiple systems even. They could represent the landscape. They could represent the infrastructure. They could represent pretty much anything I would like them to represent. And then I use variations of these rectangles to, create distinctions between these different elements. And I obviously figure out ways to connect them. A block diagram doesn't necessarily need to contain everything. That's why you need to think about your diagramming as, layers. What are the layers you want to show? And you also need to think of this diagram as a snapshot in time, a snapshot of the system at a very particular moment doing a very specific thing. Because it's very difficult to create a block diagram of a system in every single possible moment or every single possible variations of the state of that system. It's going to be pretty much impossible. So what you would want to do is to create a simplest diagram possible. And what I like to do also is to start from the outside and go inward, as opposed to start from the inward and go outside. And the reason I like doing that is because it helps me think of the boundaries of the systems immediately from the get-go. I immediately start thinking about the domains, that I'm operating within. If I have different entities, I can represent them with bigger boxes, and then I can put the systems within these boxes. And that allows me to think also about my network connectivity. How are these boundaries going to connect together, and how are they going to, integrate? Now, the level of granularity of these diagrams and the details is up to you to figure out, and you need to use your best judgment here, because sometimes you know pretty much everything about what you're designing, but other times you need to do some research. And what I like to do is to put in a lot of placeholders. So for example, you might be working with systems that you have no clue how they work. You have no clue what are their interfaces, what are the protocols that they use for integration. So I would normally put them as, just boxes, placeholders that I can come in later, revisit them, and redefine how they work within the grand scheme of things. Now, at this stage also, I would highly encourage you to forget UML, forget C4 model, forget all of these other, diagramming frameworks. This is your playtime. And I really stress the idea of play, because you want to get a feel for what you're working with. You need to have the freedom and lack of constraint from all of these frameworks. You don't want the constraints of the frameworks on top of the constraints that you uncovered by discussing the what and the why and the when. These already uncovered a lot of constraints for you. You don't want to also be blocked by how you're gonna be putting your ideas in a visual form. You want to liberate yourself from all of this. So forget all of these frameworks and just consider this as a free-form thinking and your personal time to play with all of these ideas put together. I generally like to create 3 or 4 or even more, but at least 3 or 4 iterations of every single diagram, no matter how complex it is. And in each iteration, I work on adding more detail, refining the representation of the different elements, refining the components, and more importantly, removing what is unnecessary. Diagrams are complex enough. You need to remove everything that makes them more bloated. And then I work on combining and splitting things as I see fit. Now, while you're working on your design, I want you to remember these two very important things. Number one, everything in software architecture or system design is a trade-off. You can never build the perfect system that solves for every single variable. I'm telling you, it's impossible. Some things have to give so that other things work. And the second thing you need to remember is, if as an architect you think you have discovered or designed something that isn't a trade-off, then more likely than not, you have not identified the trade-off yet and you're missing something. Now, I love these two laws because they summarize our work in a very nice way. They are the brainchild of Mark Richards and Neil Ford. They have a book called The Fundamentals of Software Architecture. There's going to be a link for that book somewhere in the description. I highly encourage you to go and give it a read. Don't consider it, the go-to reference for software architecture that you're going to learn everything there is about the field there, but it has a nice summary of the history, of the different challenges you're going to be facing. It covers a lot of the stuff that I talked about today, in much more depth, and it gives you a lot of different perspectives you can think of software architecture at. So it's a great starting point. Nobody can capture everything about this field in a book or a video or whatever, but it's going to put you on the right path. Now, for some more insights, while you're designing, I've often heard the analogy of, system design being more like fitting puzzle pieces together, as if every component is a puzzle piece and you just need to figure out a way, to connect it to some other piece. I personally think that this analogy is very detached from reality. And just like all analogies, they never really, model the reality 100%. So always take them with a grain of salt. But I think a better analogy for system design would be that it is more of an optimization problem. So in my opinion, system design is closer to the traveling salesman problem than it is to be a puzzle that you plug in the different pieces together. And I say this because in system design, you have so many variables, you can never satisfy all of the conditions together. This is where the first law of system design or software architecture comes into play. Everything is a trade-off. And this is also a trap that a lot of junior engineers and maybe junior architects fall into, is that they design something and they think their design is just perfect. Soon, they will realize how wrong they are and they will become a little bit wiser. It's very difficult to create a model representing all of these different variables and how they play together. With certain systems that are very, very simple, that might be possible. So for example, when you create a state diagram, that represents a very simple system and it shows you all of the different states it could be in, and if certain conditions are met, you can jump from one state to another and then another, so on and so forth, until you reach an end state and you already have a starting state, right? So this is a model of a system. But when we talk about complex systems that have a lot of different moving parts in them, that have a lot of different conditions they could be in, that these systems all by themselves cannot be represented in a state diagram or whatever, or a state machine, right? They're not necessarily state machines. They have a lot of emergent behavior maybe. Then this complexity is so big, we can never really capture it in a model, let alone put it in a small diagram or maybe even write it in documentation. That's why distributed systems are complex. And then by this fact, or knowing this fact, you might ask, so why do we even do system design? Like, what's the whole point of it if really it does not even capture how a system should behave or should work? It's not even a blueprint that software engineers can build on top of. Well, my opinion about system design is you are creating a visual representation of a collection of ideas. And by doing that, you're creating a medium or a mechanism for communication with others. With system design, you're creating a language, a common language that you as an architect, along with the teams of software engineers and maybe even the stakeholders, could all understand and align on. And that is the importance, way more than these diagrams being able to represent what is going to be built. You are creating a language that everybody is going to be able to use so that there is no miscommunication. So that when the product owners are talking to software engineers, they are using the same language, because in our field, there's just no standardization. And each word that is utilized could mean so many different things in different contexts. So when you do system design, this is pretty much what you're doing. You're unifying everybody's ideas about what needs to be built and how we need to approach building it with your diagrams, with whatever deliverables that are going to be coming out of this process. These diagrams also help make the discussion and conversation less abstract, because whenever we talk about the what, everybody's going to start creating mental images of what we're going to be building. So when we talk about a certain piece of software, everybody's going to think and imagine it in a certain way. But if we create diagrams for these components, then there's no need for people to take a lot of freedom in imagining things. They can just look at this representation, and when this representation is described with the appropriate context and all of the information necessary, then we're all aligned. And in my opinion, this is the actual true value of, doing system design. Now, moving on, I would also normally introduce other types of diagrams at this point. So once I've done my preliminary thinking, I have a very good idea of what the system should look like, all of the different elements that come into play, I start introducing other diagrams if necessary to cover and uncover some of the complexity associated with other parts, or maybe even if I want to zoom in to some specific element of that system, I want to represent it in a different way to increase the level of comprehension of others of this specific part. So I mostly often rely on flowcharts, sequence diagrams, or maybe even state diagrams. There are a lot of other stuff like class diagrams, EERs, and all of that fun stuff that I rarely use. Sometimes in the context of databases, I use the extended entity relational diagrams. These are very, very helpful. But if the database is too big, then yeah, that becomes very annoying to use. And honestly here, I would recommend that you use whatever you think makes sense. Don't try to get a diagram and try to fit it into a problem. Look at the problem, inspect it, and then try to find a diagram that easily represents the ideas you want to convey. And honestly, don't shy away from figuring out new mechanisms and new ways to visualize and represent information. Like, I see a lot of people getting stuck in these frameworks as if they are the Bible and the only way to do things. Forget about that. It's okay to create your own new language as long as it's easy for others to also, absorb and digest. And this comes a little bit with experience. Like when you're beginning, you want these constraints of the frameworks because they are highly opinionated and they guide you towards a specific path. But as you build more skill, there's really no reason for why you cannot really start inventing new diagrams or new representations of information. Now I can hear this question in the back of my mind. What software do you use? What other tools do you use? Of course, you don't do everything on a pen and paper, and that's correct. Lately, I've been relying a lot on my iPad to do all sorts of, diagramming and brainstorming work. And my go-to apps on the iPad are Notability and Concepts. I like both of them because they're very easy to use, and honestly, Concepts provides me with an infinite canvas, and I love this concept because I can zoom in indefinitely, I can zoom out indefinitely, and I have a gigantic canvas that is my playground, where I can freely create components, move them around, shuffle things very easily, create multiple iterations of my diagrams in the same sheet without, having to switch context a lot and jump from one thing to another. Now, remember, all of this work is more of an art than it is a science. So again, it's a lot of craftsmanship here, right? The first diagrams I did were just so ugly and horrific. And then with time, as I practiced this more and more and more, my diagrams became more coherent. I'm able to create them at a much faster pace. It just becomes easier with time. And what I want you to remember is to focus on these few things. Think of all of this stuff when you're doing your diagram as layers. The first layer should only focus on your components, the different elements of the system. Make sure you have a justification for why these components need to be there. If there's no justification, take them out. Diagrams are already messy. You don't want them to become more messy. Think of the second layer as your data flow. How are these components talking to each other? What are the integration points? What protocols are you using? Is there a network flowing in between these components? What are the boundaries? How does this data flow? Is it directional, unidirectional? Is it broadcasting? There are infinite scenarios here. I like to think of my third layer as the metadata, or everything that is necessary for people to try to understand this diagram without me explaining it to them. So for example, I would add a legend. I would maybe add, a numbering system showcasing, because I told you a diagram is a snapshot of a system in time that is representing a certain state that the system can be in. So for example, if my system is doing some transaction or some activity, I would have numbers, for each single interaction point, and I would have a description associated with that number of what is happening at that particular point in time. And I found this to be a great way to explain the system without necessarily me being there and talking about how all of these different components play together. Because the data flow, it might show the connections, that's true, but there is nothing, the time dimension is not necessarily reflected. And the way you would want to represent the time flow, actually not time flow dimension is not presented. So the way you would want to represent the time flow and what's happening from at T0, T1, T2, T3, T4 is by having these numbers and explaining what's happening at each specific point in time. Now, once you have all of these drafts put together, you've done iterations on them, so many people have seen them, they provided you with feedback, they have included what they think is necessary. Now is the time to refine your diagrams and make them a little bit more representable, especially if you're going to be publishing these diagrams and they're going to be consumed by a public audience. For this, I like to use draw.io or Lucid Charts. At some point, I was using OmniGraffle. Just use whatever tool you're comfortable with. I mean, forget the templating. The templates that are available with these tools, they can help, but I would not use them a lot. I would create my own, stencils. I would create my own icons and all of that stuff. Not create, I would just collect them, honestly. And then I would use them. But sure, figure out the tool that is easiest to you to use and just start with that. At the end of the day, all of what you're going to be doing is just going to be, drawing borders and connecting and aligning arrows and all of that fun stuff, which is the part I hate the most. Because whenever someone comes in with a comment or feedback at that point in time, I feel like I just want to tear my hair apart or whatever hair I have left, because it's not really fun to reshuffle and restructure. That's why my recommendation to you is do all of the feedback collection on your drafts that are far easier to modify than when you get to the stage where you put them in draw.io. I see a lot of people start with tools like draw.io or Lucid Charts. I highly discourage you from doing that. Now, another alternative to these things is I highly rely on stuff like PlantUML or Mermaid.js, whatever it is, so I can write code, not necessarily code, it's more of a DSL or a domain-specific language. So they have a domain-specific language written for these tools, and then you can describe the different components and create the relationships with them. And then you can render, this file into an image or a visual representation. So you can create a sequence diagram using the DSL. You can describe different lanes, and then you can describe the different flows and what are the communication protocols used and all of that fun stuff. And then you can just render the visual. And I love these because they're very simple to use. They're easy to edit, way easier than when you're doing the diagrams yourself by hand or using whichever app. And I love the fact that you can also put these as close as possible to the code base. And in the case of Mermaid.js, for example, GitHub renders it. So if you create a diagram, you just need to append the DSL text in your MD file and GitHub will just render it for you. Now, I can already hear a lot of people say, but Bassem, why do we need to put in all this effort in creating these diagrams that are just going to be obsolete as soon as we start writing code? And you're 100% correct. These diagrams are going to be extremely obsolete and very quickly, and sometimes even totally incorrect. However, there are three important things to consider. One, not all systems and code bases change as rapidly as others. So in SaaS companies, your code base is probably going to be changing on a daily basis, new features introduced on a weekly basis, deployments and rollouts and all of that stuff is happening probably every day. In other places, that might not necessarily be the case, and diagrams might have a longer shelf life. Number two, as I mentioned, the main purpose of diagrams is to create a language to align all of these different teams on what we are building and how we are building it. And for that, in my opinion, to create this common language and alignment, the effort spent on creating these diagrams is 1000% worth it. I would rather spend hours and days building diagrams like that we create a very high level of alignment between different teams who might not know each other or between different organizations than us building the wrong thing. And trust me, I've seen this a billion times. And every time, diagrams save the day. A lot of people are visual thinkers. A lot of people want something tangible. A lot of people cannot reason with abstractions alone. And not everybody is a developer. Diagrams solve a lot of these problems. Number three, if whatever is built is as close as possible to the diagram, diagrams can be updated. And diagrams, even if they're not a 100% representation of reality, can still be used within the context of meetings to discuss variations and the changes and how the diagram is not necessarily a reflection of the truth. And we can discuss also what has varied and what is still correct. Now, the last stage of all of this fun stuff is storage. I personally like to put my diagrams as close to the code base as possible. Doesn't really matter how you structure your projects as long as you and the team are aligned on where you are storing these and you are consistently maintaining them. Obviously, at some point, the law of diminished returns starts to kick in and maintaining these diagrams becomes more effort than the benefit that they bring, especially when everybody within the team really knows all of the intricate details of the systems you're working on. If you need to start engaging with external teams, and if external teams frequently need to understand the changes that you are applying and that are happening within your boundary of ownership, maintaining these diagrams would definitely make much more sense, and it will alleviate a lot of the pain and frustration associated with code ownership. At the end of the day, you need to be the judge and you need to do what's best for you and for your team and the resources that you have available for you. I know I talked a lot, but I hope that what I've shared with you is insightful and you managed to learn a thing or two from it. I will be making more videos in the system design series, and hopefully the next time what I will do is I will take a scenario and we will use all of what I've just talked about today to show you how all of that works in practice. Until then, I wish you all the best and I will see you next time.